Imagine standing on top of Mount Everest. At 8,849 meters, it is the highest point on Earth. Now imagine that same mountain flipped upside down and submerged into the ocean. It wouldn't even come close to the bottom. The ocean is not just deep. It is incomprehensibly, terrifyingly, beautifully deep. And most of it, we have never seen. In fact, we have better maps of the surface of Mars than we do of our own ocean floor. As of today, humans have explored less than 20% of Earth's oceans. What lives in the other 80%? What hides in the dark? Today, we are going all the way down. Before we dive in, we need to understand the scale of what we're dealing with. The average depth of the ocean is 3,688 meters. That's roughly 2.3 miles. Picture the Eiffel Tower stacked on top of itself 9 times over. Now stand on top of that imaginary tower. Look down. You're still not at the bottom of the average ocean. But the ocean doesn't stop at average. The Atlantic Ocean plunges to 8,376 meters in the Puerto Rico Trench. The Indian Ocean's deepest point, the Java Trench, sits at 7,187 meters. And then there's the Pacific. The Pacific Ocean covers more area than every single landmass on Earth combined. And it hides the deepest place on the planet, a scar in the ocean floor known as the Mariana Trench. At its deepest point, a slot-shaped valley called Challenger Deep. The ocean floor sits at 10,935 meters below sea level, nearly 11 kilometers down. Let that sink in. If you dropped a steel ball into Challenger Deep, it would take over an hour to hit the bottom. If you somehow transported Mount Everest there, the world's tallest mountain would be completely swallowed, with over a mile of ocean still above its peak. The pressure at the bottom is 1,086 times the atmospheric pressure we feel at sea level. It's the equivalent of 50 jumbo jets sitting on top of your body. This is not a place built for humans, but humans went there anyway. We'll get to that. Scientists divide the ocean into 5 distinct zones. Each one is a different world. And as we descend through each layer, the rules of life itself start to change. The first zone is the one we know best, the sunlight zone, stretching from the surface down to 200 meters. This is the ocean we swim in, the ocean of coral reefs, sea turtles, dolphins, and sharks. Sunlight penetrates this layer, fueling photosynthesis, feeding the food chain. 90% of all marine life lives here. It's beautiful. It's familiar. But below 200 meters, the sun disappears. From 200 to 1,000 meters lies the mesopelagic zone, the twilight zone. Sunlight barely reaches here. Temperatures plunge. Pressure intensifies. And yet, life adapts. The creatures here have evolved extraordinary tricks. Many are bioluminescent. They generate their own light from chemical reactions inside their bodies. In a world of total darkness, they glow. The lanternfish, the hatchetfish, the firefly squid. The twilight zone may contain more fish by weight than all the world's surface fisheries combined. It is one of the least understood ecosystems on Earth, and scientists believe it plays a crucial role in absorbing carbon dioxide from the atmosphere. What we don't know about this zone could change everything we think we know about our climate. Below 1,000 meters, we enter the bathypelagic zone, the midnight zone. No sunlight, no photosynthesis, crushing pressure. This is where the ocean starts to feel truly alien. Creatures here look like nightmares. The anglerfish dangling a glowing lure from its forehead to attract prey in absolute darkness. The vampire squid, despite its name, not actually a squid, that turns itself inside out when threatened, revealing a cloak of spines. The giant squid lives here. For centuries, sailors told legends of a sea monster that could drag ships to the bottom. They called it the Kraken. They were not entirely wrong. The giant squid reaches lengths of up to 13 meters, 43 feet. It has the largest eyes of any living animal, the size of dinner plates, evolved to detect the faint bioluminescent flashes of predators in total darkness. Scientists didn't photograph a live giant squid in its natural habitat until 2004. Until then, Everything we knew came from dead specimens washed ashore or found in sperm whale stomachs. The midnight zone keeps its secrets well. From 4,000 to 6,000 meters lies the abyssal zone. Abyssal comes from the Greek word abyssos, meaning bottomless. Temperature hovers just above freezing. Pressure is 600 times atmospheric. No light has touched this floor in millions of years, and yet it teems with life. Sea cucumbers carpet the muddy floor, processing sediment like earthworms of the deep. Pale, ghostly fish drift slowly, conserving every calorie. Bacterial mats grow around hydrothermal vents, cracks in the ocean floor where superheated water rich in minerals erupts from below. These hydrothermal vents are one of the most significant discoveries in modern biology. Life around them doesn't need sunlight. It doesn't need photosynthesis. It runs on chemosynthesis, deriving energy from chemicals rather than light. This discovery fundamentally changed our understanding of where life can exist, not just on Earth, but across the universe. If life can thrive in total darkness, under crushing pressure, with no sunlight, what does that mean for the icy moons of Jupiter and Saturn? For Europa? For Enceladus? The deep ocean didn't just change oceanography, it changed astrobiology. And then there is the final zone, the Hadal zone. Named after Hades, the Greek god of the underworld. These are the ocean trenches, the deepest cuts in the planet's crust, formed where tectonic plates collide and one slides beneath the other. They begin at 6,000 meters and plunge all the way to the bottom of the world. And even here, life exists. Hadal snailfish have been filmed at depths of 8,336 meters, a world record. They look like pale, translucent ghosts. Their skulls are not fully fused, a structural adaptation to the pressure. Their cells contain a chemical called TMAO that prevents proteins from being crushed. The bottom of the ocean is not a dead place. It is an alien ecosystem that has evolved over millions of years under conditions that should, by all logic, be incompatible with life. For most of human history, the deep ocean was pure mystery. Ancient Greeks believed it was the domain of gods and monsters. Medieval sailors feared sailing off the edge of the world. The ocean floor, the actual bottom, was entirely beyond imagination. That began to change in 1872 when HMS Challenger, a British Royal Navy warship, set out on a 4-year scientific expedition. Using a weighted rope, a technique called sounding, the crew dropped lines over the side and measured depths across the globe. When they reached the Western Pacific and measured 8,184 meters, they had no idea they were hovering above the deepest place on Earth. They named their discovery Challenger Deep. 150 years later, we still use their name. The first humans to actually descend to the Challenger Deep did so in 1960. Jacques Piccard, a Swiss oceanographer, and Don Walsh, a US Navy lieutenant, climbed into a submersible called the Trieste. It was essentially a steel ball bolted beneath a float full of gasoline. No luxury, no comfort, a tiny porthole, a single flashlight. They descended for 5 hours. At 10,916 meters, deeper than any human being had ever gone, they landed on the floor of the Mariana Trench. And through the porthole, in the beam of their light, they saw something that stopped them cold. A flatfish, a shrimp, alive, on the floor of the deepest place on Earth. In that moment, everything changed. The deep ocean wasn't a dead void. It was a living world. For 52 years after Piccard and Walsh, no human returned to Challenger Deep. Then, in 2012, director James Cameron, the man behind Titanic and Avatar, climbed alone into a custom-built submersible called the Deep-Sea Challenger and made the solo descent. He spent 3 hours at the bottom, collecting samples and filming footage. His deepest dive reached 10,908 meters. Cameron later said it felt like being on another planet. Flat, desolate, utterly alone. Lonely in a way that few humans have ever experienced. Today, a new generation of deep-sea explorers is mapping the ocean floor with unprecedented precision using autonomous underwater vehicles and remotely operated vehicles equipped with HD cameras and robotic arms. Each expedition brings back new species, new data, new mysteries. In 2019, retired naval officer Victor Vescovo descended to 10,928 meters in Challenger Deep, the deepest crewed descent ever recorded. What he found was extraordinary and disturbing. At the bottom of the world, in a place no human had visited in decades, he found plastic bags, a candy wrapper. Even the deepest place on Earth is not untouched by us. The ocean covers 71% of our planet's surface. It produces more than half the oxygen we breathe. It absorbs about 30% of the carbon dioxide we emit and regulates our climate. It drives weather patterns across every continent. Without the ocean, Earth is Mars. And yet we know more about the surface of the moon than we do about our ocean floor. Only about 20% of the ocean floor has been mapped with high resolution. The rest is estimated using satellite data, rough approximations, not detailed maps. This matters. Deep-sea mining companies are preparing to excavate the ocean floor for rare earth metals, cobalt, nickel, manganese, minerals critical for electric vehicles and renewable energy technology. But we don't know what ecosystems those mining operations will destroy because we haven't mapped or cataloged what lives there. We are considering dismantling a world we've never fully seen. The deep sea is the largest living space on the planet. By volume, it makes up about 95% of the habitable space on Earth. All the forests, all the grasslands, all the mountains, all the tundra, all the places where land creatures live and breathe and die. That's just 5% of Earth's habitable volume. The other 95% is deep ocean. We live on a thin skin of this planet and have convinced ourselves we understand it. We don't. Down there in the dark, species live and die that have never been given a name. Chemical reactions fuel ecosystems that have no sunlight. Ancient geological processes churn along the ocean floor. Some deep-sea creatures live for centuries. The Greenland shark, which dives to depths of 2,200 meters, can live for over 500 years. The individual you see in footage today was born before Shakespeare wrote Hamlet. The ocean holds time differently than we do. We began this journey with a question. How deep is the ocean? The answer is simple. 10,935 meters at its deepest point. Nearly 11 kilometers, a number we can write on paper. But that number means nothing until you feel it, until you imagine what it means to fall downward through 11 kilometers of salt water, through zones where light exists to zones where it doesn't, through pressure that crushes steel and cold that would kill you in minutes, through clouds of glowing creatures and past the slow drift of ghostly fish, through a world that has existed for hundreds of millions of years without us, that had complex ecosystems, evolutionary arms races, its own chemistry and physics, long before the first human ever looked at the ocean and wondered what was in it. That is how deep the ocean is. But here's what stays with me. Every deep-sea expedition, every single one, comes back with footage of species never seen before. New fish, new worms, new microbes, new behaviors, every time. We have been studying the deep ocean for over 150 years, and it still surprises us every single time we go back. The most alien world we have ever discovered isn't on another planet. It is beneath our feet, right now, beneath the surface of the blue water that covers most of this Earth. It is full of life. It is full of secrets, and it is waiting. The ocean does not need us to believe in it. It does not need us to explore it. It will go on existing in darkness and silence long after we are gone. But for our sake, for the sake of wonder, I hope we keep going down.